Okay, hello everyone. Now we are coming to the most important topics of this chapter, that are Green's theorem, Stokes' theorem and Gauss divergence theorem. Okay, you need to remember the statement of this, then you need to know how to apply it. Okay, these are very important as one question is sure shot from coming from this thing. Okay, what does Green's theorem say? For example, there are two functions phi and psi, and like phi y and psi y be continuous in region R of xy plane. Like you need to remember this whole this basically just remember this line, that's most important. Over here we are converting the line integral basically into another form. Okay, we are like kind of surface integral. Okay, let me make you understand it through an example. Over here curve which is defined by this axis, x equals to 0, x equals to y, x equals to 0, y equals to 0 and x plus y equals to 1 line. Okay, so how are we like this is the curve. So for integrating simply with respect to curve without using the Green's theorem, it would have been like you need to integrate first the whole equation with respect to this line, and then the limits would be of this line, and then the limits would be of this line. So you need to do all these processes thrice. That would be very like you need to just find out the line integrals that we have done in the first video, you remember? And then like how we do line integral for C1, for example, y line would replace y value as 0 and then just varies x from 0 to 1. Okay, that's how we normally do. Okay, but that's a very calculative compressing process. Instead we can use Green's theorem that says we can directly do it as a surface integral. We know like for surface integral we need to make a strip. Okay, this strip basically where it is going from 0 to 1 minus x, like this line is basically x plus y equals to 1. Okay, so when we make x as y as subject, it would be 1 minus x. So this line is basically, this strip is basically going from 0 to 1 minus x, and then we can move this strip from 0 to 1, okay, in x direction. So this is how the limits come over here. Okay, and then I done nothing but del phi. What is del phi? Like this this is basically phi. I have differentiated it with respect to x, so what it would be minus 6x minus 6y. Okay, and this term I have differentiated with respect to y, phi. This phi I have differentiated it with respect to y, so what it would be minus 16y would be my minus 16y. Already over here my one minus sign is there, so minus minus would be plus 16y. So this whole into dy dx. Okay, so now just solving this and I'll get answer as 5 by 3. So this is much simpler than doing the whole line integral for 1, 2, 3. Okay, and but one most important thing in this question is the form that is given. Over here one function is been integrated with respect to x, and the other function is been integrated with respect to y. Okay, then only we can apply this Green's theorem. Okay, I hope this is clear to you. This is practice 1 or 2 questions with respect to this, and then it would be clear. Thank you.